Good day, everyone. This project looked at alternative sanitizers to be used in the palm fruit industry. There are very few sanitizers available for the palm fruit industry. And even though there are sanitizers available, we're unclear how effective they are in sanitizing the water and the fruit that go into it. We also another problem is we don't know how long chlorine will still be available, or how much it will be restricted on how high the dosage may be for exports. So we do need alternatives for chlorine in the near future, and to increase our sanitation processes at our pack houses. So the aim is to test, to identify sanitizers and test these sanitizers, firstly to see how they deal with killing botrytis and penicillin spores, and then how well they can sanitize fruit. So running through our materials and methods, first we had to identify and source a few of these sanitizers. We got 7 to include into the study. Thereafter we did in vitro study, where we looked at how they would kill or inhibit botrytis and penicillin spores after a very quick contact time and plating onto PDA plates. After that, we got packhouse water from 5 packhouses, and we spiked some of those water sources, whether it be from the source, the tap, or from the flume, contaminated flume water, or already used flume water, and also with a very brief contact time to see if it would sanitize that water and kill or inhibit any of the spores we spiked into it. With that results, we finally identified the sanitizers we would like to include into our in vivo studies, and to the fruit sanitation, where we sanitized apple and pear fruit contaminated with botrytis and 6-month spores. So all the trials actually have been done. The final one is just in storage currently, and we still need to evaluate the findings. So here we have the results from the in vitro study done on our 7 sanitizers we sourced, and how they compare with chlorine. Please consider this is only results from botrytis. In this case, specifically with botrytis, best cure did quite well. This was not the case when best cure was tested on penicillin. It was only Kilza and potassium sorbate that showed no results. The rest of the sanitizers showed some form of efficacy, and that of hypercide also doing very well. Hypercide actually did quite well on penicillin. So from here we could exclude at least Kilza and potassium sorbate as potential sanitizers. Okay, here we included a low concentration of chlorine with some of the sanitizers. We definitely saw an effect with only a 30 ppm chlorine greatly contributing to the efficacy of hypercide, and then also potentially to best cure. So this shows the results after treating water from packhouse 5. The source water is not shown here, but the source water from packhouse 3 and 5 was clean, and it was not heavily treated at all based on the high coliform unit from spiked samples. So here we have the flume water. The flume water was contaminated since we had high coliform units on treated and untreated plates. But the hypercide and chlorine showed quite good sanitation of the water, even with water samples spiked with botrytis and penicillin spores. Best cure was effective only with considering with botrytis. So packhouse 1 and 2 and 4 was not shown, had good source water, but was heavily treated with low coliform units. The flume water was also very clean due to it being heavily treated in packhouse 1 and 2. Packhouse 4, it was not as heavily treated because, since the spiked samples showed some coliforming units. So from this we can really see that hypercide showed a good sanitation of the water, and it was quite in comparison with chlorine, and best cure obviously doing very well against botrytis. please consider that the method we used was quite strict based on a low contact time. So the sanitizers that weren't included in the further study can potentially have good efficacy based on further optimization and how to handle them. Thank you.